Now we will find out the height of a cloud using 1 and 60 rule. Height of cloud. In an aircraft, we have an equipment which is known as the weather radar. The weather radar transmits a frequency ahead, and the cloud reflects the transmitted frequency, and from that received signal I can find out the distance or the range of that cloud from my aircraft. So let us say that this is a wave which is transmitting in front of the aircraft. We'll make a kind of a cone. This is the axis where it is transmitting, and this is the periphery of the wave I am transmitting. The wave is concentrated in this direction, and that there will be no frequencies or no signal which will be transmitted outside this. This angle is what we call it as a beam width. This beam width may be in a horizontal plane, beam width in the horizontal plane. Okay, if the weather radar is scanning like this, the weather radar wave scans left, right like this. Any cloud which is coming in front of me will reflect my signal back, and I will receive this signal back once again, and I will time out the time taken, and using the same formula, distance is equal to velocity of light multiplied by the time, I can find out the distance of the cloud from my aircraft. This beam was scanning like this, am I right? But this beam will have a vertical expand also. The wave is transmitting and the scanning like this. We have a control with which I can change the angle at which the beam is looking. It may look straight, the level where I am flying. I can scan it above my flight path. I can scan it below my flight path also. So generally when the aircraft is flying on a straight and level flight, that is at a particular altitude, okay, at that point of time, the axis of the beam will be aligned to my flight path, and the tilt angle, it is known as a tilt angle will be 0. Right? If I see some cloud above me, obviously I can tilt it up. If I see some cloud below me, I can tilt it down. Normally on a weather radar, this beam width is maybe depend upon the company which manufactures, but generally it is about 5 degrees. Now if I have a particular cloud at a particular distance, is my wave touching the cloud? Will there be any reflection from this cloud? So there will be no reflection from the cloud, so there will be no pickup on the weather radar. Okay, so the weather radar will look blank like this. Okay, so now let us say that the cloud has grown in size and start touching it. Now I will have some pickup from this portion of the cloud, am I right? And the weather radar will start painting. When the painting means when the reflection of the cloud is being shown onto the weather radar scope, it is what we call it as a painting on the weather radar. Okay, if the cloud continues to grow its height, it will paint now. Let us assume that this is an aircraft flying here which has got the weather radar, and at a certain distance there is a cloud. We do not fly through the rain bearing cloud because of the turbulence. and because of many dangers which you have learned in the meteorology. The primary aim is to avoid these clouds. You can go sideways and avoid it, or you can fly higher or lower. So we generally avoid it sideways. But at the same time, we can also find out the height of the cloud. If the height of the cloud is very, very large, okay, then the cloud is generally dangerous to me. Okay, you see that cloud which looks like a cauliflower, okay, in the sky. Those clouds are generally known as a cumulus or cumulonimbus. If the height of these clouds vertical extent is very, very high, they become dangerous, and we have to avoid at a greater distance. So we need to know the height of the cloud. Let us find out how much will be the height of the cloud. How do we find out? Let's talk about the theory first. And I have a weather radar whose beam width is 5 degrees, and I am at 0 degrees tilt. That means to say that exists of this weather radar wave transmission is like this. Since it will have a particular beam width, it is the extent up to which it is transmitting, and let's say the beam width is 5 degrees. The cloud will be painted on my weather radar screen because the waves are coming back after reflecting from the weather or the cloud. Now, in order to find out the height of this cloud, I need to know, okay, that this is at 0 degrees and I am flying at, let's say, 36,000 feet. At 0 degrees, when I'm flying it, I'm at 36,000. Now I will slowly pull the tilt of the weather radar up, up, up. Okay, now till the time the cloud finally disappears. At this point of time, the lower beam has just crossed the cloud. Okay, where let us say that the particular beam, this is the place from where the beam tilt is measured from, right? Let us say that this is, once the tilt is 3 degrees up, the cloud disappears. Completely disappears from my screen. So now I need to find out this particular angle. And as I know from my weather radar, let's say this is at a distance of 90 nautical miles. Now, this particular angle is 3 degrees. And since the beam width of this weather radar is 5 degrees, as I mentioned in the beginning, right? This is 5 degrees. And how much will this be angle? This angle will be half of the beam width, that is 2.5. Isn't it? This is, I will write it in a different color. This particular angle is what we call is a half beam width, which is 2.5 degrees. So now this angle will now be 3 minus 2.5. 3 degrees is the tilt up and the beam width is 2.5. So this particular angle will be the tilt angle minus the beam width. Which is equal to 3 minus 2.5, which is equal to 0.5 degrees is this angle. We know that the cloud is at a distance of 90 nautical miles. So this height can be found out using 1/60 rule. So using 1/60 rule, we can find out that theta is equal to this height, this particular height h divided by 90 multiplied by 60. That is theta is 0.5 is equal to h unknown 90 into 60. So h is equal to, this is 2 and this is 3. 0.5 into 3 divided by 2, which is equal to 0.75 nautical mile. Now we have found out that the height of the cloud above my flight level is 0.75 nautical miles. We generally do not express the height in terms of nautical mile. We express them in terms of feet. So I need to convert this decimal 75 into feet by multiplying it by 6080. So now decimal 75 multiplied by 6080 equal to 4560. This is 4560, right? How much is the height at which I am flying? The height at which I am flying is already at 36,000. So therefore, the height of the cloud above the mean sea level will be 4650 plus 36,000, which is equal to 0650 40,560. So a cloud which is above me when I'm flying at 36,000 feet, which extends up to 40,000, is a very big and huge cloud, and which is going to be a dangerous one. So I need to avoid this cloud by at least 25 miles.